Hi everyone, so I will be discussing Leetcode 1.855 problem maximum distance between a pair of values. So in this problem we are given two non-increasing zero-indexed integer arrays nums1 and nums2, and basically a pair of indices ij is valid if I is smaller than equal to j and nums1 of I is smaller than equal to nums2 of j, and the distance between that valid pair is j minus I, and we have to find the maximum distance of any valid pair given the two arrays. So let's discuss what is a non-increasing array. So a non-increasing array would be basically something like which is, let's say, 100, 40, 40. This is non-increasing because it is not increasing. From here it is decreasing, and then it is stable here. So non-increasing does not necessarily mean that it would be strictly decreasing. It would either be the consecutive values would either be decreasing or it would be same. Now let me discuss through this example what the problem statement is asking. So for this example, there is 55, 35, 40, and 100, 20, 10, 10, 5. So now when I is 0, when I is 0, which means the nums is 55. Nums of 0 is 55. Now we have to find um, a greater value than 55 in this array. So you can see clearly that it is 100. So you basically just say that uh, at j is equal to 0 we find a value greater than 55 and rest of the values are small. Now for I is equal to 1 nums of 30. Now um, here j is basically greater, j is for j is equal to 0, 100 is greater than 30, but we cannot consider this j because we have to make sure that I is smaller than equal to j, which means that we can only look in this part of the array. So in this part of the array there is no value which is greater than 30, so there is no answer possible from here. Now for I is equal to 2, nums of 2 is 5. So for this 5, the minimum value, the greater values, all these are greater values, but if you see we want maximum distance. Now maximum distance for this would come from this last index only. So for any given index we would want to find um, the last index such that the rightmost index such that nums of j is greater than equal to nums of I. Now for this I equals to 2, the right we can only see at this part. So this is also greater, this is also greater, this is also greater, but this one is equal. So but we would only consider this index because this would give the maximum answer. So b4. Similarly for I equals to 3, it would be nums of 3 is 4, and again j would be 4, and for I equals to 2, nums of 3 is n of 4 is 2 and j is 5. J is 4. So the maximum we have obtained, the maximum distance obtained from here, which is 2. From here the maximum was, the distance was coming 0. From here distance is coming 1. From distance is coming 0. So the maximum is 2. Now the reason for finding the rightmost value such that it is um, greater than, it would be greater than this. Why would this be true? Because the array is non-increasing, which means that if this 5, if we know this index is greater than this, or greater or equal to this index, then that means that all these arrays, all these elements would also be greater than this 5, because the array is non-increasing. So let me discuss the solution to this problem. So basically, what I have done is just loop through this nums I array. So the nums I array is 30, 2, and then for example, for this 55, I am finding the index which is great, the rightmost index which is greater than this 55, and for that I am applying binary search. So for this 55, I is 0 and j would come 0. For I1, j would not be possible. For for I2 it would be 4. For I3 also it would be 4. And for I4 it would also be 4. So the maximum would be 2. So this is what I am doing here. I am applying max after each iteration. The time complexity of this solution would be log n plus log n minus 1 plus so on log 1, which is also log n into n minus 1 till 1. This is also log n factorial, and space complexity would simply be O(1) because I'm not using any auxiliary space.